All right, boys and girls, next up. So it's the third example. This you should immediately see is different than the others because we do have a discontinuity. So if I kind of spoil this out, I'm going to need this for the limits here in a second. I can also call this x squared plus 1 over x. If I put it into one rational expression, I can see clearly that x is not allowed to be 0, right? And that we can't, so we have that is an asymptote behavior right there that we need to consider. There are no zeros. There is no place that x squared plus 1 can equal 0, so there's no x-intercepts. And since x can't be 0, there's no y-intercepts. There's none of those. I can see that. I kind of have a general framework of rational expressions having like those kind of shapes. I don't exactly know what it's going to look like, but I'm kind of expecting something that looks like that. So then I want to think about, okay, well, what about these asymptotes? So let's take the limit as x is approaching 0 of f. And as x approaches 0, from the right, what's going to happen is not indeterminate, unfortunately. It's 1 over 0, so that's just undefined. So then I just have to think about it. As it gets really, really, really small, what happens right here is this value stays small. But this value, as x gets small, blows up really big. Super, super, super positive. So this guy actually goes to infinity. And then, moreover, as the limit as x approaches 0 from the right of f, the same idea. This gets really, really small and negative, but this gets really big and negative. Or I should say really, really, really small, negative, big absolute value. So this actually comes out to be negative infinity. And that actually doesn't use any of our 4.5 knowledge. It's just what we did in chapter 2. Like really, you could justify it on a table or just your understanding of the graph as you get bigger and bigger and bigger and smaller and smaller. So then I am going to go ahead and take the limits as x approaches infinity to get those endpoints of f. Now in this case, I do end up with an indeterminate. I get infinity over infinity. So that's the same as the limit as x approaches infinity. And if I look at this graph or this equation, I'm going to use L'Hopital. So that's the same as 2x over 1 using L'Hopital. And now I can see that that's going to turn to infinity, right? And if I used a negative infinity in that equation, that would be a negative infinity. So that kind of helps me out with my end points. That means as x goes to positive infinity, it's going to go up forever. And as x goes to negative infinity, it's going to go down forever. So it has endpoints, it's going up versus down. And then I definitely have this asymptotic behavior at 0. So it's going to infinity on the right-hand side, and then it's going to negative infinity on the left-hand side. So what do I know? I know there's no x-intercept, there's no y-intercept. I know that I have an asymptote at 0, and it does the John Travolta like that. And I know that it's going to go infinity as the two infinity sides. As x goes to infinity, I don't have any kind of horizontal asymptote, just the vertical asymptote. So now let's go ahead and create our table. So when I put the table up, I will have also found the critical points and the points of inflections. I just won't have found all the values. Okay, so now I have my table with my derivatives. We start from the beginning. I first changed my function to that for easier derivative finding. First derivative. switched it back to positive exponents, put it into one ratio, and that's where I found that my x's could be positive or negative 1, which makes my critical points positive, negative 1. Second derivative was really easy to find from there. No points of inflection. However, I do have an asymptote that we discussed. So now I need to consider my concavity and my increasing or decreasing on either side of that asymptote. Technically, this is a CP as well because the function doesn't exist there, so increasing, decreasing could change there, concavity could change. So I need to consider on both sides of the asymptotes. So now I'm going to fill the table in. Okay, there's the completed table. Notice what I have right here. Sure enough, that matches with what I found. From the left, it's going to go to negative infinity. And from the right, it's going to go up to positive infinity. So you could almost draw this like this. Down to negative infinity, because that's what we found. And up. And that can kind of be drawn on right there and right there. So that matches with the asymptotic behavior that we kind of discovered. So everything looks pretty good. So I think we're ready to graph. World's worst stylist. Stylist comes again. Okay, so we have a trending down. As we go to negative infinity, it goes down like that, and it goes to positive infinity up like that. I'm going to put those endpoints there. Switch to pink. And so then I have at negative 1, I go down to negative 2, and that's a max. And then I know I have an asymptote happening here, so it's going to go something like that. And then at 1, I'm at 2. And then right before it hits 0, it's going to go up to positive infinity, basically, based on our asymptotes. And then it's going to go up. Now, I'm not feeling like this is enough information for me to get a really good sketch of the graph. So I found a couple of other things. I went negative 2 was my value there. And I found out this was negative 2. And then this was over here. I used positive 2. Accidentally turned my graph off. So there's 2. And I found out this was 2.5, negative 2.5, and I found out that this was 2.5. And so that gave me just enough extra to kind of see right there. And then 2.5. It gave me just enough extra to see what the shape of the graph was, so I could see it a little bit better that it did that, and I could see it just a little bit better that it did that. And that's what the shape of my rational expression looks like, rational equation. And let me add, if that wasn't enough, you can add additional points anywhere along here to get a shape of like how the graph is curving if you feel like based on the information, you don't have enough to actually get a sketch of the graph. You can figure out a couple of extra input-output. You know that this is a min. You knew that this was a max. So truly, it probably should be more like that. I'm just having a hard time drawing it on this. But you don't know necessarily what the curve is doing after that. And so especially out here, like, it's a big question mark. Like, what exactly, how is it sloping out there? What is the linearity like? So you might want to add additional points just to get a better perspective of the graph.